We're going to look at how to use circle properties to find missing measurements. In the question that we're given here, we're asked to find the length of QR. So QR starts here at the edge of the circle and extends down to the edge of our triangle here, R. The other information we're given is that O is the center of the circle and that the radius of the circle is 2.2 meters. So I'll go ahead and fill in that information anywhere I see a radius. I see a radius here from O to the center of the circle to S. OS is a radius. So I know that's 2.2 meters. And I also have another radius here going from O, the center of the circle, to Q, so that's also going to be 2.2 meters. Next, I see that I'm told that S is a point of tangency, so that tells me that the line SR is a tangent line to this circle. So the line SR is my tangent line. And I have a property that relates the tangent line to the radius of the circle. That property is our tangent radius property. Our tangent radius property tells us that anytime we have a tangent line and a radius meeting at a point, we have a 90-degree angle. So that tells me that this angle right here is 90 degrees because, again, our radius and tangent line are going to be perpendicular according to our tangent radius property. So now we have a right triangle. We know one side of the right triangle because it's a radius. We know another side of the right triangle, which was given in the question, the 4.3 meters. And we're looking for this little piece right here, QR. QR is not a side of the triangle, but it's part of a side of the triangle. If we find the side OR, we'll be able to chop away the piece we don't want and be left with QR. And since we have a right triangle, we can find our missing side OR of the right triangle using our Pythagorean theorem. Our Pythagorean theorem relates the sides of our triangles as a squared plus b squared equals c squared. And in our case, since OR happens to be the hypotenuse in our triangle because it's across from the right angle, our OR is going to be our C value, and A and B will be our 2.2 and 4.3. So we can use Pythagorean theorem to find OR, and then we're just going to hack off that little piece at the end that we're not looking for. So our A squared, our A value is 2.2, so 2.2, we're going to square it. We're also going to square our other side, our other leg, 4.3, and we're going to find that missing side. 2.2 squared, or 2.2 times 2.2, is 4.84. 4.3 times 4.3 is 18.89. I'm going to go ahead and add those two guys up, and we'll get 23.33. That's our value for c squared. We're not looking for the square of the side, we're looking for the side itself. So we're going to need to use square root to find the value of c. And the square root of 23.33 is about 4.8. So c is about 4.8 meters. And of course that was our hypotenuse of our triangle right here, which we have as OR. Now that we know OR, all we need to do to get that little piece we're looking for, QR, is to hack off the part from O to Q, which we know is 2.2 because it was a radius of our circle. So we have QR that we're looking for is equal to OR, that side of the triangle, and we're going to subtract the piece we're chopping off, OQ. So that's going to be OR, we just found was 4.8 meters. Take off the 2.2 meters that we're not looking for, and we're going to get a final answer of 2.6 meters for QR.